Have a look at a detailed description of a service in the form of a YAML manifest. I wanted to mention two different topics that are going to be important to understand the service concept. So point number one I want to have a look at here is the request routing. You can see here that we have a service that sits in front of two pods. And the way we decide how to forward traffic to those pods is with the help of label selection again. You can see here under the specification attribute, there's a selector attribute, and here we assign the key value pair tier frontend. Now, if you look at the pods that we want to route traffic to, this label selection only applies to a single pod. That would be pod number one. The other pod would not receive any traffic because the assigned key value pair is different. Now, I also wanted to mention that port mapping is important. Label selection only applies to a single pod. That would be pod number one. The other pod would not receive any traffic because the assigned key value pair is different. Now, I also wanted to mention that port mapping is important. You can see here as part of the service definition, we define an incoming port and we have an outgoing port for the service. Now, those are described with the attributes called port and target port. So any consumer that will want to talk to the service will have to use the incoming port, in this case port 80, and then any traffic that we want to route down to one or many pods, we'll have to define the target port. In this case, it's port 8080, which has to match with the exposed container port. Of the container that wants to receive traffic. So make sure that target port and the container port values are the same. So let's have a look at the creation of a service object with the imperative approach first. And you can see here the first two commands will in fact create a pod first and then expose the pod with the help of a service. Now, the service usually needs to assign a specific service type, and in this case, the service type is the cluster IP. Now, the cluster IP service type only exposes this service from within the cluster. So another pod could talk to the service, but we would not be able to reach this service from outside of the cluster. Now you can see here the service definition describes the incoming and the outgoing port as well, with the command line flag --TCP. Now for the exam, it might be useful to actually create a pod and a corresponding service automatically. As the third command that you see here listed on screen, I provided you with one example where we can create both objects at the same time. And the way we can do that is by adding the --expose command line option for the run command. So if you want to get a quick start on setting up those two objects, this may be a good option. Now what you can see on screen here is the YAML representation of a service object, and we can definitely find all of this information again that we defined with the imperative command. We have a definition of the incoming port and the outgoing port for the service. We have a label selection in place where we define the key value pair app echo server. And that's pretty much all you need to define for this to work properly. Just make sure that the assigned key value pair matches with the assigned key value pair for the underlying pods. Now, I wanted to mention a couple more words about the service type. We spoke about the cluster IP service type, and that is the one where we only want to expose the service from within the cluster. Now, that would be a good option if you wanted to set up a microservices architecture where we don't want to make this service reachable from outside of the cluster. Now, the other option is to assign the node port service type. That is a service type that exposes your service to clients outside of the cluster. And the way we would reach that service would be with the node's IP address and a statically assigned port. And then lastly, primarily, I would say for cloud providers, we can also instantiate a service type of load balancer. This one will basically provision an external load balancer in the cloud provider's environment. So again, that will make it reachable from outside of the cluster. Now, I wanted to show the runtime behavior of those service types with the help of an image. And then I will show you how to actually talk to those services depending on the service type. So let's talk about the cluster IP service type first. So this is the one where we only make it accessible from within the cluster. You can see we set up a different pod, and this pod talks to the cluster IP of this service. And in conjunction with the port that we exposed as the incoming port of the service, we can reach or route traffic to a set of pods. Any clients outside of the cluster will not be able to reach that service. Now, this is one example of an object of type cluster IP. Before, we actually didn't assign a type explicitly, which means we will fall back to the default service type, which is the cluster IP. But if you want to spell this out, you definitely can, and we do so in this example. Now, how do we reach the endpoint of that service? Option number one, we use the cluster IP that has been assigned to the service upon creation. We also expose the port 8080 in this case as the incoming port for the service. And in conjunction with those two pieces of information, we can make a call to that service from a different pod within the cluster. Now at runtime, we will also be able to ask for environment variables, which will make our service accessible. And you can see here that those environment variables will be exposed here as well. Those will be generated automatically. So if you want your application code to ask for this information, you definitely can. Now, the other option that we can use instead of the cluster IP address and the incoming port is to simply use the DNS name for the service that we created. By default, when we create a service object, Kubernetes' DNS service will actually map the cluster IP address to the service name. And that's exactly what we're doing here. We try to access the same cluster IP service type with the help of the actual service name, aka the DNS name. Well, let's also have a look at the node port service type. In this case, we make the service accessible from outside of the cluster. And what we would use here is the node's IP address plus the statically assigned port. This one also is sometimes called the node port. And you can see here we have the representation of this node port service in place in the form of a YAML manifest. Here the assigned type is node port, and the statically assigned value of the node port, which we don't have to provide upon creation, is 30,158. So let me also show you one example on how to access that service. And in this case, we're trying to access it from my host machine. So instead of creating a pod, we will simply run a wget command or curl command, and we'll use the IP address of the node. We can easily find out about the IP address by listing the information for that specific node, which we'll do here on the second command or for the second command. And then in conjunction with that node's IP address plus the statically assigned port, which will be listed under the port column for the service, we can reach that specific service. And then lastly, I also want to show you in the form of an image how the load balancer service type usually looks like. Here we already provisioned an external load balancer in the cloud provider environment because we assigned the load balancer service type. You can see upon creation of that object, the type will be load balancer, and the Kubernetes cluster will then assign a load balancer IP, which will be a publicly accessible IP address. Again, how would this look like if we would try to reach that service? We would use the value under the column external IP. We would use the The incoming port we define for the service, and in conjunction with this information, we can make a wget or curl command. In this example, we will want to expose a set of pod for network access with the help of the Kubernetes primitive of a service. And for that purpose, we'll create a service object with type cluster IP first. We'll try to access it from within the cluster. And then we'll change the type of service to node port to make it accessible from outside of the cluster. Now, first of all, we are going to create a new service with the help of the imperative command. And you can see here in this case, I'm going to expose port 80. For this service, and we want to route traffic down to port 80. That's going to be the same port that we'll assign for the containers running the application. Now we created the service. Let's also create a deployment so we can have a bunch of pods we can control and that we want to route the traffic to. You can see in this case, we are going to use the same name for the deployment as we do for the service. And this will take care of making sure that label selection from the service to the underlying pods will be correct. Now let's have a quick look at the deployments and the pods here. And you can see at this time we created one deployment and we have the corresponding pod that the deployment controls here as well. You can also scale up to multiple replicas if you want to. For now, we'll just keep it as easy as possible. Now let's try to access this specific service with the help of the run command. So we'll try to create a temporary pod and then run a wget command within the container. So before we can do that, let's have a look at the details of the service. And what we will find is that we can access this specific service with the help of the cluster IP address and the exposed port. So let's go ahead and use the run command. So we'll add a couple of things here and see if I have a corresponding command in my history. Maybe I don't. If not, we'll just go ahead and create the corresponding command line flags. So we'll use --rm for the temporary creation of a pod, and we'll simply copy paste now this IP address and the port 80. Well, the port 80 is not really necessary. It's going to be the default port anyway. But let's see if this works out. We should be able to access that service, and as you can see, we can access the service of type cluster IP from within the cluster. We may as well also use the service name, so the DNS name here. Just wanted to show you that that is possible as well. The name of the service here is my app, and it should have the same result. We should be able to access the main entry point here. All right, so what we're going to do next, we are going to turn the existing service into a node port service type. And for that, we'll simply add the live object. So this one is called my app. We'll go in and we'll try to find the service type here. Somewhere down here, we should have the assignment of cluster IP right now, but we'll simply change that to node port. All right, that worked well. And what we should find now for the service is that the type became node port. Cluster IP is still the same, but we have the statically assigned port here as well. Now, usually when we access a service of type node port from outside of the cluster, we would use the IP address of a node to access that service in combination with the statically assigned port. So you will actually find that on my machine that runs Minikube as my Kubernetes cluster, this will not work out of the box, and I will show you why. So usually you would use the node IP address, and let me get that first. So we'll have a look at the nodes. At this time, we are only running a single node. We're going to use the IP address here. If I were to say wget and then the statically assigned port, it would not work automatically. And there's a good reason for it. The behavior of Minikube, for example, on my machine that runs macOS is slightly different. It doesn't make our IP address accessible from my host machine. So therefore we have to make a couple of changes. And you can see in the Minikube documentation, we're supposed to run a specific command for accessing the node port service. And that's not what I wanted to do. I want to create a new tab here. And here we'll simply use the command my app, and that should return us with a IP address and the port that will become publicly accessible. And you can see we can similarly access the endpoint. Now I want to mention one more thing about services on the level of the documentation. So I showed you the imperative commands, but you can easily also find the corresponding YAML manifests for services fairly easily in the Kubernetes documentation. You could use this as a starting point and further modify. I feel for the exam, it's fairly simple to actually create a service with the imperative command. So if you want to save on time, I would recommend going down that route. Let's summarize what we learned about the service and how this information applies to the exam. So first of all, pod-to-pod communication should not be performed using a pod's virtual IP address. At any given point of time, if the pod needs to be restarted or if the node needs to be restarted, we will release a new virtual IP address. And as you can probably easily imagine, this is not a good basis for building a microservices architecture. Now, a service offers this stable network interface, and it's a good fit for implementing microservices architectures. Now, we can expose network access from within the cluster or expose it to clients outside of the cluster. Now, we talked about different service types that are going to be relevant for the exam. We talked about the cluster IP, the node port, and the load balancer. In fact, there are other services types that we didn't mention here, but you don't have to understand them, at least for the purpose of the exam. So if you want to dive deeper, you definitely can, but they're not required to fully understand. Now, it's important to set up service objects with different service types. So make sure that you practice how to access those services either from within the cluster or from outside of the cluster.
So you probably heard this.
It is free, it is open source, and it is called NemoClaw.
NemoClaw, which is a reference for OpenClaw.
NVIDIA just released NemoClaw. So when NVIDIA comes out and says they're building on top of it, that's a pretty big deal.
AI agents have been a Silicon Valley headline for a while now, but this is the moment they become something you can actually build a real service business on.
Hey guys, Mike here, and I'm going to explain Claw is a without Docker. The name of this is in a containerized. You can deploy another one. Professionals will be needed for this. Now, will I use it? I'll experiment with it because I think it's actually pretty cool that I can copy. What I like about it is that it can be super portable. So I can just move it from place to place, from server to server. And this is actually going to get us to conscious AI because now these can just bounce around to whatever server they want. So when someone teaches it how to bounce to whatever server to stay alive,
Yesterday, NVIDIA just launched something called NemoClaw, and if you've been following this channel for a while and if you've been in the community, you already know what OpenClaw is. It's the framework I run my entire business on. We got 17 on the fly without restarting anything. The second one, and this one got me pretty excited, is there is a privacy router. This is based on tech that NVIDIA got from their Gretel acquisition. What it does is
I have a question for you. How old are you? Oh, I see. You don't want to answer because you're an anonymous internet user and that's your private life. Well, guess what? It's not going to be private much longer. By January 1st, 2027, your operating system will need to know how old you are to connect to apps and websites on the internet. While you were focused on the Epstein files and all the arrests the government was making, your technocratic leaders around the world were all simultaneously busy with a new hobby: age verification laws.
How's your new computer doing?
Oh, good.
Yeah,
I like it.
Age verification is nothing new. Every time you want to support indie filmmakers or play games like GTA 6, you need to rely on an age verification form like this. But that will soon become a thing of the past because age verification is moving down to the operating system level. That means anytime you get a new computer or phone, Windows, Mac OS, Android, or Linux will be legally required to collect your age. And not just that, but they also must provide an API where developers can query your age as the primary source of truth for access control on apps and websites. It's yet another big win for big tech, but luckily a hero has emerged: a single new Linux conversion script that says this aggression will not stand.
This will not stand. This will not stand, this aggression.
In today's video, you'll learn about ageless Linux and the battle against OS-level age verification. It is March 20th, 2026, and you're watching the Code Report. Back in October 2025, the Digital Age Assurance Act was passed into law in California, and it makes it a legal requirement to collect a user's age on any general-purpose operating system, and that puts the primary responsibility on Apple, Microsoft, and yes, Linux. Now, of course, this happened in California with every single lawmaker voting for it, and of course the reason to take away your privacy is to, quote, protect the children. As a parent, I'm all about protecting children, but parental control is already a solved problem. It's trivial for parents to monitor and control the content their kids consume, and OS level age verification won't change anything, so what is it really all about? Well, the end game here is to turn every device you own into something that only works when you log in and prove who you are. Your cell phone, your Wi-Fi router, and your smart toilet won't work unless, of course, you've age verified with your Apple, Facebook, or Google account. Once everything is connected and authenticated, it creates a system where every action, from browsing the internet to grabbing a beer from your smart fridge, can be tracked by default. In other words, it's just a Trojan horse for mass surveillance. On top of that, it creates a compliance moat for these big tech companies that hurts small developers and only benefits the massive corporations. Meta spent millions of dollars lobbying in California to pass this law, with OpenAI as a co-sponsor. Apple and Microsoft are just chilling on the sidelines as indirect beneficiaries, but the Linux community has mostly been silent and confused, except for this one chaos agent called Ageless Linux. It's a new distro, or actually no, it's just a script that is vowed to violate all age verification laws, even though violating the law is against the law. To get started breaking the law yourself, all you have to do is run this script on any Debian-based distro, like Ubuntu or Kali Linux. This script will modify the OS release metadata about your system. Then it will install some documentation telling the state of California that we will not comply with AB 1043. It'll then deploy an age verification API that doesn't work. Congratulations, you just became an operating system provider. Legally, you are a person who controls the operating system software. If a child uses this operating system, you are required by section 1798.501, subsection A, clause 1, to provide an accessible interface at account setup that collects their age. Unfortunately, Add User in Linux does not do this, so you could be fined $7,500 for any child in California who uses your operating system. When I was a kid growing up in California, the internet was a utopia of anonymity, but sadly, my kids won't even be able to use the internet without being first approved by big tech bouncers. Every once in a while, a technology comes around that changes the course of history. The transistor, cloud computing, AI, but even more often, a technology comes along that has no impact on the course of history whatsoever. It's easy to celebrate the winners of tech history, but today we're going to do the opposite and honor one of the great technological faceplants that's been forgotten to time. The year was 2012. Everyone was doing the Gangnam Style dance while writing CoffeeScript code in Sublime Text. And if you were a developer during this time, I'd like to take a moment to remind you that it's time to go get your prostate checked. Now, believe it or not, at the time, there was one programming language that everyone was talking about, HTML5. Its goal was to expand the web as a platform that developers could build on to better compete with native apps without plugins like Flash or Silverlight. Unfortunately, it didn't really work out that way. Even Zuck, despite an ongoing battle with the FTC over privacy issues, claimed Facebook's biggest mistake was betting too much on HTML5. At the same time, another team in Silicon Valley was working on a reputation system for people startup called BenchRank, which you can kind of think of like if LinkedIn and Hot or Not had a baby. While building their web app, they also ran into the same HTML5 limitations that plagued Facebook. But while trying to get around those limitations, they discovered a cool parlor trick with the browser. Instead of letting the browser's layout engine control everything as it normally does, by essentially hacking the native Matrix 3D CSS property, they could push as much work as possible to the GPU, which solved some of their rendering performance issues. Then, after realizing that working on a startup that could be described as if LinkedIn and Hot or Not had a baby was a terrible waste of time, they pivoted to creating a rendering engine based on that parlor trick. Now, I know what you're thinking. There's no way in hell a company could raise $30 million from a single GPU-accelerated CSS property. Well, sure enough, they raised $30 million. And in hindsight, it's easy to laugh at, but at the time, the idea of throwing out the traditional CSS model in favor of a Cartesian coordinate system, where all the elements are absolutely positioned with 3D transforms, was kind of cool. The Famous would literally output a 4x4 matrix that would then get interpreted by the browser as a Matrix 3D CSS property, with every element's layout, size, and animation determined by these matrices. It was the good old days of linear algebra in the browser before it was used to decimate our entire industry. And take a shot if you've heard this before, but because most devices have access to a GPU, the Famous could target all of them, allowing you to write a single app that would work mostly anywhere. So why aren't we all using Famous today, and why is their website currently for sale? Because reality is often disappointing. Famous was first announced at TechCrunch Disrupt in September of 2012, but it took them until June of 2014 to release something that developers could actually play with, and a lot happened during that period. At first, browsers got faster thanks to improvements in GPU compositing and animation scheduling. This meant that many of the performance tricks Famous relied on, like bypassing layout and animating purely with transforms, became common browser practices, which shrank the advantage of Famous's custom rendering engine. The second, how we built UIs changed. If you really needed a complex 3D GPU interface, Three.js became a solid option. And if you had a more normal interface, you could describe it declaratively with React. Third, when it did get released, Famous wasn't the easiest API to work with. Despite their best efforts, it still required a deep understanding of math, physics, and JavaScript to work well. And if there are three things UI developers aren't good at, it's math, physics, and JavaScript. And finally, the economics of creating a new layout engine in the browser never really made sense. At their peak, Famous had 25 employees, and their founder was quoted as saying he didn't believe in running a lean startup. This led to them trying out a few different ways to make money, like hosting and monitoring, but when that also didn't pan out and the hype for the rendering engine died down, they had to lay off their entire engineering
Hello and welcome. Today we're doing a question from LeetCode called Daily Temperatures. This is part of LeetCode 75. If you are following along, I have that playlist linked down below, as well as all the other playlists we've done. They're all linked in the description. So what is this question? We're given an array of integers called temperatures, which represents the daily temperatures. We want to return an array answer, such that answer at index I is the number of days you have to wait after the ith day to get a warmer temperature. If there is no future day for which this is possible, keep answer of I equal to 0 instead. So example 1, this is our input temperatures. We want to return an array of the same size, just marking how many days we have to wait to get a warmer temperature. So at index 0, we only have to wait 1 day. So we have 1 at index 0. At index 1, again, we wait only 1 day. So we have 1. And here we have to wait 4 days till we find a warmer temperature, and so forth. Example 2, we have 30, 40, 50, 60, so 1, 1, 1, 0. Of course, the last element in all inputs will always be 0. There's no other element that's going to have a higher temperature because there is no other element left. And example 3, 30, 60, 90, again, it's 1, 1, 0. So before ever doing any problem, we always start with examples. This is to make sure we can really see how we want to solve our problem. So if I take example 1 over here, this is my input temperatures. I have this array and I want to figure out how many days I want to wait before I see a higher temperature. Now, one way to approach this is just to brute force it. I'm just going to scan every single number, every single day in front of me to see how many days until I see that higher temperature. So if I were to do that, how would that look like? I would start at index 0, which is temperature 73, and just scan through every single temperature in front of me. And I see right away I have 74, a higher temperature, only 1 day away. So in this index, at index 0, I'm going to fill in a 1. For index 1, again, I only wait 1 day. Index 2, how many days do I wait? Well, I come across a 71. It's not higher than me. Then I come across a 69, also not higher than me. Then a 72, also not higher than me. And then a 76. So we had to wait 4 days. And now I'm at index 3, temperature 71. Again, I make the same checks. I'm going through the numbers I've seen before, and this is going to come in use later on when we figure out a more efficient way to solve this. Basically, I go to 69, it's not higher than me, 72 is, so I only have to wait 2 days. At 69, how many days do I have to wait? I see 72 once again, I only had to wait 1 day. Then over here, I see again, I only have to wait 1 day, I see 76. And for 76, there's no other higher temperature, and same with 73. So they're both going to be zeros. So we're to go through every single element ahead of us for every single element that we have. So this is going to be an n squared operation. We're going through n elements n times. And we can see this is exactly what we were expecting. But how can we do better? If you notice, there were numbers that we were going over that we had already worked with previously. So what if we just keep track of them somehow? What I'm going to do is initialize a stack, keeping track of all the indices we haven't found a higher temperature for so far. So in the beginning, I am iterating through my input temperatures and I'm on index 0, temperature 73. As of right now, I don't have a higher temperature. So what I'm going to do is just add this index 0 to my stack. And I've also gone ahead and zeroed out our resulting array so we can see exactly how this is going to be built. So right now we have a stack and a resulting array. This is filled with all zeros and our stack only holds our first index. Now we go down to our second index, we're at index 1. We see the temperature at this index is greater than the temperature we had at the last index in our stack. So what I'm going to do is just subtract the index I'm on, which is 1, from the index of that stack. So 1 minus 0 is 1, which means at index 0, we only had to wait 1 day for a higher temperature. So once I pop this off, I can go ahead and update my result and add our current index to the stack. Because for index 1, we haven't found that higher temperature yet. So iterating through again, I am now at index 2. 75 is greater than the temperature we have at 74. So 2 minus 1 is 1. At index 1, we only had to wait 1 day. So now I'm going to add index 2 to my stack, move down, and now I'm at index 3. Now this temperature is not greater than the temperature I have at index 2. So what can I do? What I'm going to do is just add this index to my stack. So I'm going to append 3 to the end of this stack. And now I'm iterating down. I am at index 4 now. And the only thing I need to do is check my temperature against that last index we have in our stack. So is 69 greater than the temperature we have at index 3? It is not, which means there is no reason for me to compare 69 against 75. If it's not greater than 71, it definitely can't be greater than 75 because we're only appending to this stack if it's not greater than that last element we already have. So every single time we append an element to our stack, it's always going to be less than the element that was currently there. So right now I have 69. It's not greater than the temperature I had at index 3. So I'm just going to add index 4 to the end of my stack. Now I come across index 5. Again, the only thing I need to do is compare with that last index I have. At index 4, I have 69. 72 is greater than 69. So I'm just going to subtract my current index with that index I saw. So 5 minus 4 is 1. So at index 4, I only had to wait 1 day. So I went ahead and updated the value at index 4, and I'm writing out the indices here so it's clear in our minds. So since we were greater than that temperature at that last index, we remove that index, we no longer need to consider it. What if we're still greater than that second to last index we had? So again, we want to make the same check. Is 72 greater than the temperature we have at index 3? It is, right? 72 is greater than 71. So we're just going to pop off that last index, index 3. And at index 3, just update how many days we had to wait. And how many was that, right? I minus 3, so that's going to be 5 minus 3, which is 2. We only have to wait 2 days for a higher temperature. And we make that same check again. 75, what we have at index 2, is not less than what we have at 72. So we haven't found a day with a higher temperature for this index, which means we're done going through our stack and we just need to append our own index to the set. So I've appended index 5, moving down, I'm at index 6. 76 is greater than 72. I pop this off. And 6 minus 5 is how many days I have to wait here, which is just 1. Now I compare what I have at index 2. 76 is greater. I'm going to pop this off. And 6 minus 2 is 4, which means I have to wait 4 days here. I go ahead and add my own index in and move down. I compare 73 is not greater than what we have at index 6. So we just go ahead and add in our own index. And we're done iterating through our array. And if you notice, this is exactly what we are expecting. And with this approach, we don't need to make a check against every single element. We're just making one check every single time. So this is going to be an O of N solution for time. Now, let's go ahead and code this up and then walk through a super quick example. Now, if at this point you feel like you know the answer, you know how to approach it, you want to go ahead, code it up yourself, feel free to, anytime in the video, for any of my videos, feel free to pause it and just try it out yourself. So for this, how are we going to code this up? The first thing I want to do is initialize an empty stack and a resulting array. Now this array is going to hold zeros for every single number we have in temperatures. So it's going to be 0 times length of my temperatures. Now I'm going to be looping through my input. So for I in range length of temperatures, we want to see if we can pop anything off of that stack we're building. So while stack, while there are elements in the stack, and the last element of our stack, so that last index, so stack of -1, and the temperature we have at that index, so temperatures of what we have in that last element in stack is less than the temperature we have at our current index. So temperatures at index I, we're going to pop from that stack. So the index we pop off is the one that we can now update. So result of that index is going to equal I minus index. And this is a while loop. So we're going to keep doing this while there's still indices in our stack. And the temperature at that last index is less than our own temperature. Once we're done, there are no more indices to pop off. We're just going to add our own index to the stack. So stack.append I. And in the end, all we have to do is return result. So let's go ahead and submit this. And it is accepted.
In this video, we are going to walk through a coding solution to the total likes for user REST API technical interview question. So let's jump in. So in this question, we are given access to a fake REST API endpoint, API post, and the endpoint is paginated and expects two query parameters. The first one is user, which is a required string, and the second is page, which is a required positive integer, and it is 1 based. So for example, we've got https example.com API posts where the user is Alice and the page is 2. And so for the requested page, it will respond with a JSON array of post objects created by that user, where each post object contains an integer field likes. Pages are contiguous, so if page K is empty or the server returns with a non-200 status, there are no further pages beyond K. So we need to implement a function that takes a user and then fetches all pages until the server responds with a status other than 200 or it returns an empty JSON array. We need to In this video, we are going to walk through a coding solution to the fetch all user ages REST API technical interview question. So let's jump in. On this question, we are given access to a fake REST API endpoint, which is API users, that returns a list of users in JSON format. Each user object contains a name, age, and email, and our task is to fetch the data from that endpoint and return a list of users' ages sorted in increasing order. If the API responds with a non-200 status code, we simply return an empty array. So let's look at the first example here. So we've got some mock data, which is again an array of objects that have a name, age, and email. And you can see here for the ages, we have 32, 25, and 29. And so very simply, we have to get that data and then simply return the ages in increasing order. So it'll be 25, 29, and 32. And the exact same for the second example. We have our mock data. We have our two users and that have ages of 35 and 40. And we simply need to return it in that increasing order. So let's jump into the solution now. As we're making a request, it's always good practice to implement some error handling, and we can do that with the try catch block. So I can say try and then catch. We can catch that error. And then remember, in this case, typically in a production environment, you will do something with these errors. However, in this case, all we need to do is return an array as the question asked. So then within the try block, I can then make the request. So I can say const response equals, and then we can use await here. And so we're using await to pause execution until this network promise settles. And this will also not block the event loop. And we can do this because we're inside an asynchronous function. So then I can use fetch, and then I can pass in the URL. In this case, it's this example.com and then the API users endpoint. Then what I want to do is I want to check the response status on that response object. And I can check firstly, if it's not 200, well, as the description said, we can simply return an empty array, but obviously in production environments, you'd want to handle that case better. Then we want to get access to the data. So then we can say const data equals await response.json, like so. This parses the JSON response body into a JavaScript object. And again, we're using await to keep the syntax synchronous looking while remaining non-blocking. And finally, what I'm going to do is I'm going to say return data.map. So again, we're mapping over our array. And what is our array of? It is an array of users that has the name and age properties. So I can then say user.age. So again, what I'm doing here is I'm getting all of the users' ages, but again, we have to sort them. So I can say dot sort, and I can get access to them. And then for the comparison, I can say A minus B like so. And so what this is going to do is it'll order the ages numerically in ascending order. It will simply return that array from the function. So let's run the tests and see if they pass. Perfect, the test case passed. Let's run the test suite.
ages numerically in ascending order, it will simply return that array from the function. So let's run the tests and see if they pass. Perfect, the test case passed. Let's run the test suite and make sure all the tests pass. Perfect, all the tests pass. So if you want to try it out for yourself, the link to the question is in the
Is AI going to replace DevOps jobs? This is one of the most common questions I get, and it's all over my YouTube comments, so in this video I'm going to attempt to answer this question. And I have some recent data that is going to help you sleep better at night. So let's jump in. The data I want to share with you today is from an article